Hello everyone, welcome back to physics online classes. In the previous video we discussed about Ohm's law, its definition, as well as we discussed about an activity that explains about Ohm's law. In this video we are going to discuss about one of the important concept, that is resistance. That is resistance. What is resistance? So resistance nothing but the property of obstruction of flow of electrons is called resistance. So resistance means nothing but the property, the character. What is that character? What is that property? Obstruction of flow of electrons through the conductor. No, well, for example, if you assume that it is as a conductor, so electrons are flows through a conductor when it is connected to the battery. While these electrons flows through the conductor, so when electrons are flowing through this conductor, by depending upon the nature of the conductor, that conductor have a character, a property. That property nothing but a obstruction of the flow of electrons. While these electrons are moving, there is a obstruction. That obstructing character is called resistance. That obstructing character is called resistance. So resistance nothing but the obstruction, the stoppage of the flow of the electrons in the conductor is called resistance. Actually it is denoted with a letter R. So R means it is nothing but a resistance. Do you know one more thing? The materials which have resistance properties is called resistors. So resistors nothing but the materials which have the property. What is that property? Resistance property. They are called resistors. So resistance means obstruction of the flow of the electrons in the conductor is called resistance. Resistors means the material which have the property resistance. They are called resistors. This resistance nothing but the ratio of resistance. Already we know resistance, or resistance equal to V by I. We know already formula. The ratio of voltage and current is called resistance. So this resistance, the resistance power depends upon different factors. Now I would like to teach about what is the relationship between resistor and resistance and different factors. Let's start that. We discussed about what is resistance. This resistance of any conductor is influenced by some factors. The factors affects on resistance of conductor. So by depending upon these four factors, the resistance of the conductor is depends. So the first factor is temperature. What is the first factor? Temperature. By depending upon the temperature, the resistance power is depends. For example, if you take a simple circuit by connecting a bulb, look at here, these are the connecting wires. and it is a battery, and it is a ammeter to measure how much current flows through the circuit, as well as it is a key to switch on, to switch off. Then I am connecting a bulb to the wire. It is a bulb, the circuit, it is glowing, and I will connect these two ends of the bulb to the multimeter. What is the main function of the multimeter? To measure resistance, to measure resistance. Okay, fine. Now pass electricity for few minutes. After few minutes, by switch on the circuit, we can observe the temperature of the bulb increases. The temperature of the bulb increases. At the same time, the resistance value of the current circuit. So the resistance value of this circuit you can find out in the multimeter. So in the multimeter, the resistance value also increases. So temperature increasing means what will happen? Resistance value also increasing in the multimeter. That means what? So temperature T directly proportional to the resistance R. So you can write in another way, resistance directly proportional to the temperature, directly proportional to the temperature. So resistance increases means temperature also increases. So temperature increases means resistance increases. So this is the relationship between temperature and resistance power. What about nature of the material? Second factor that influence on the resistance of the conductor. So nature of the material also influence to increase resistance. How? For example, to find it, let's do an activity by using simple circuit. So it is a battery, and it is a ammeter, and it is a key, and these are two are connecting wires. These two connecting wires ends are leave them itself. So this end is a P end of the connecting wire, it is a Q end of the connecting wire. Now take different materials like a nichrome, manganese, copper, silicon, etc. Take different types of the materials and place that conductors, nichrome conductor or manganese or copper or silicon, connect them between these 2 points P and Q, and observe the, now connect a multimeter to it and observe the readings of the multimeter. If you observe, is the value of the resistance is same for these all materials? No. Is the value of the current is same for all these materials? No. So the resistance of any material depends upon its nature. The nature of nichrome is different, the nature of the manganese wire is different, the nature of the copper wire is different, the nature of the silicon wire is different. So these are the different materials manufactured with different characteristics, different properties, different natures. That's why these all natures are same. That's why the resistance value also not same. The resistance of the any conductor depends its nature. This activity gives a clearance to the resistance depends upon the nature of the material. The third one, length of the conductor also influence on the resistance of any conductor. Look at here, I am taking same circuit again to perform an activity to prove that the length of the conductor also influence on the resistance. Look at here, now take same kind of wire, like same kind of copper wire. So nature is same, copper wire, but with different lengths. One is 20 centimeter, another is 30 centimeter, and another one is 40 centimeter, and another one is 50 centimeter. Now place these different length conductors one by one between this space. So first I will take a 20 centimeter conductor and I will connect like this. between points P and Q. Again I will take 30 centimeters. Again later I will take 40 centimeters. Later I will take 50 centimeters. So different lengths I will take and replace between the points P and Q. I will connect that conductor endings to these 2 points. While I am connecting these separate length wires, I will measure the resistance of these ends of the conductor. Then I will get different values. The resistance of the 20 centimeter is less. The resistance of the 30 centimeters more than the 20 centimeters. The resistance of the 40 centimeters more than the 30 centimeters. So we can observe by increasing the length, the resistance power increases. From this observation, we can conclude resistance of any conductor are directly proportional to its length. Means length increases means resistance increases. So the resistance of any conductor depends upon its length. Length increases means resistance increases. Resistance increases means the flow of current through that resistance decreases, because we know already resistance current I inversely proportional to the resistance R. Means resistance increases means current decreases. That means the length increases means resistance increases. Resistance increases means the flow of current decreases. Next one. Next factor is cross-sectional area of conductor. Cross-sectional area of conductor. It is the length of conductor. So the resistance of any conductor depends upon its cross-sectional area. So we know what is cross-sectional area. For example, it is a conductor. This round shape wider size is called cross-sectional area. So dear students, the resistance R is inversely proportional to the cross-sectional area A. So cross-sectional area denoted with A. So resistance inversely proportional to the cross-sectional area A. We know already wider pipes carries more water. Narrow pipes, small pipes carries less water. Wider pipes carrying more water means wider wires, wider conductors carries more current. Wider wires carrying more conductor means electricity passing more means resistance is less. That means cross-sectional area more means the flow of electricity more, the flow of electrons is more means the resistance less. Cross-sectional area less means resistance more. So they are opposite each other. Cross-sectional area increases means resistance decreases. Cross-sectional area decreases means resistance increases. Both are opposite each other. They are inversely proportional. So resistance are inversely proportional to the cross-sectional area of conductor. So dear students, from this we can say the resistance depends upon different factors. The first one is temperature. Temperature increases means resistance increases. The resistance power depends upon the nature of the material, and also we discussed about the length of the material. If length is increases means resistance increases, and also we have discussed about the cross-sectional area. Cross-sectional area increases means resistance power decreases. From this I am going to derive a small formula for resistance and its units. Okay. Length of the material directly proportional to the length of the material directly proportional to the resistance means the resistance are directly proportional to the length. Resistance increases when length is increases. Are you clear? So it is the equation 1. Next one, resistance are inversely proportional to the cross-sectional area A. Cross-sectional area A. It is inversely proportional means cross-sectional area increases means resistance decreases. Cross-sectional area decreases means resistance power increases. It is the equation 2. By joining 1 and 2 equations, resistance are directly proportional to the length L and inversely proportional to the cross-section area A. Now I am substituting a proportional constant at here. So that proportional constant nothing but a rho. So rho is a proportional constant. Proportional constant. So by substituting proportional constant in this value, our resistance equal to rho L by A. This is the formula of resistance. I am writing this formula here. So our resistance R equal to the proportional constant rho and L by A. So we know already, for example, if it is a conductor, so the length of the conductor related with L. So the units of the length is meters. What are the units? Meters. So R equal to rho and length meters. So as well as cross sectional area. So cross sectional area nothing but volume. So volume means, for example, if it is a conductor, so some electrons travel from this place to this place. So the distance is m as well as cross sectional area is m. So m into m is cross sectional area. So m into m means m square. So for the units of the cross sectional area is m square. Both are cancelled at a one time m. So from this, resistance R equal to rho and meters. So rho is a proportional. So the units of this rho is, the resistance is ohms. So by removing the constant at here, R equal to ohms. This is the symbol of ohms, meters. So these are the SI units of resistance. This is the SI units of the resistance. This is today's class. I hope you understand. Thanks for watching. Keep smiling. Bye.